Hi, welcome to 1.6, determining a quadratic equation when given its roots. Okay, as we learned in previous lesson, the roots are associated with the x-intercepts of the graph. They're also associated with the zeros of the function. Our success criteria: determine the equation of a family of quadratics when given its x-intercepts. Determine the exact equation given the zeros and a point, and represent given information as a quadratic function. So as you can see here in this image, there is a bridge and the supports are in the shape of a quadratic. So if we had some information regarding this quadratic structure, could we use that to determine an equation that models that exact shape? Okay, that'll be one of our last examples that we'll focus on. For now, we first want to define what a family of quadratics is, and then we'll go ahead and do some examples with that. So, all right. So, firstly, let's define a family of quadratics. So, a family of quadratics, this is simply just a group of quadratics that share the same x-intercepts. Okay. So, a quick example of this would be, let's say we had two x-intercepts here. There are an infinite amount of quadratics that pass through here. So they all share the same x-intercepts, but they all have a unique shape. So some of these could be really skinny, some of them could be compressed. They can open upwards, opens downwards. There's actually an infinite amount of them. Um, but what they have in common is they all share the same x-intercept. So that makes them part of the same family of quadratics. So um, these individual quadratics here, they're called the members. So there's an infinite amount of members that are part of the family of quadratics. Okay, so let's do this first example. It says find the equation of a family of quadratic functions. So when you find the family, you're writing out a general equation that's going to represent all of them. So it says find the equation in factored form for a family of quadratic functions with the given x-intercepts. So these are the x-intercepts that are listed. It says sketch each family showing at least three members. Okay, so this shouldn't be too bad. We're going to go ahead and set up our axes here. All right, so this first one, this is part A. Our x-intercepts are 4 and 2, so we'll mark off 2, and then we'll mark off 4. So there are an infinite amount of these that pass through. We want to show at least three members. So first, let's define our general equation. So by general equation, I mean the equation for the family of quadratic functions. So we're going to put this in factored form. So we can say here, since x equal to 2 and x equal to 4 are the roots to the equation, okay, so we were given the x-intercepts. We know those are the roots to the equation. So we can use that to help us get the equation. If they're the roots to the equation, then that just means we can find the factors. So the factors of the function must be x minus 2 and x minus 4. Okay, so if these are the roots, okay, or the x-intercepts, it means that these must be the factors, okay? Because remember, these are like the zeros, okay? They basically are the zeros. If you plug x equal to 2 into this equation, you're going to get 0. So I can use those, and I can therefore say y equal to, actually we'll call it a function, so we'll do f of x. F of x equal to a times x minus 2 times x minus 4 must be the equation for this family. Okay, we can see here that if you plug the x-intercepts in to the equation, you're going to get your first 0, right? Which makes everything 0, so that's why it's the x-intercept. Now, this is the family equation. Okay. So we could say this is the equation for this family of quadratics. Okay. So the reason why this represents a family is because we have this symbol A here. Okay. The symbol A basically is kind of like a parameter. We could put anything we want in for A. And as we put anything we want in for A, we're going to create a bunch of quadratics that pass through 2 and 4, and they're all going to change their shape. If you remember, this A kind of acts like a vertical stretch or compression. So depending what number we put in, we can get really skinny graphs that are vertically stretched. We can get some that are reflected and a little bit wider. All right, so I'm going to go ahead and I'm going to show this on Desmos real quickly. Okay. So I just added a slider like you had seen. What that does is it allows the A value to become a parameter. Okay, so notice I created a quadratic. Right now it's going through 2, 0, and 4, 0. Okay, so that equation fits those x-intercepts. Now, my value for A, as I move the slider, I'm changing the value of A. But notice these quadratics always pass through the same x-intercepts. So this is a collection of a family that passes through. Okay, I can also animate the slider if I hit the play button. Okay, and this is just going from negative 10 to 10. I could have A go from negative 100 to positive 100. All right, so what all these quadratics have in common is they all pass through the intercepts 2 and 4. Okay, and what makes them unique is the value of A in front. If I want to find a specific quadratic, I need to have a little bit more information than just the intercepts. I need to have the intercepts and one other point. If I had one other point, then I could lock in the unique member to that family that fits. Okay, so getting back to this example, we just found in factored form, we found the family of the quadratic function. That's what we have here. So it says sketch each family showing at least 3 members. So let's show a couple members here for this. So I'm just going to compress this real quickly. And in blue, I'll say let A equal 1. So this means I'll have the equation f of x equal to x minus 2, x minus 4, because the A value is 1 here, right? There's a 1. So that's going to be a quadratic that opens up, and this is just a sketch. My vertex will be right in between the intercepts. I can show that going upwards. So I'll label this f of x equals x minus 2, x minus 4. All right, now we're going to show another one. I'll just let A equal -1 this time. So now we're going to get the reflected quadratic. So that'll kind of look the same, except it's going to be opening down. Okay, and I can plot one more member. We'll go with a really skinny one. We'll do a equals 2. So we're going to get f of x equal to 2 times x minus 2, x minus 4. So that one's going to be a little bit more stretched than the blue one. So I'm just going to exaggerate that a bit. All right. Okay, so those are 3 members, all part of this family of quadratics right here. Okay, so now we can continue on and do the same thing for B and for C, and then for D as well. If you want, why don't you go ahead and do B and C on your own. You can pause the video, and then when you join back, I'll go through and I'll do B and C. You could also try D as well, but this one's a little bit different because it only has one x-intercept. Okay, so that one's going to be a little bit special. Okay, let's go ahead and let's start B. So if you did pause the video, welcome back. So for part B, we have 2 x-intercepts. So I'm just going to go ahead and draw those graphs. So we draw the intercept. So we got one at 0. The other one is at -5. Okay, I'm not going to label this one 0. We know it's at the origin, so it has to be 0. Okay, we're going to write out the general family. So we always start with f of x equal to a. A is our parameter that we're going to change to get specific members. Now I'm just going to include the zeros or the roots. So the first one is when x is -5. So what does that mean I have to have in here? So it means I need to have x plus 5. How do I know that? Well, if we plug -5 into here, this factor is going to become 0. Okay. What about the next one? It's at 0 here. Well, that means it's really easy. It's just going to be an x. Okay, if you plug 0 into x, then you're going to get 0. So that's this factor. It's just x. Okay, now we need some specific members to this family. So we'll start with blue. And I will say, let's highlight this first. This is our family equation. Okay. Now for the members, we can let a equal 1. So we would have f of x equal to x plus 5 times x. And this is in factored form. So this quadratic will just open up. Okay, now we'll pick another one. We'll let a equal -1. So that will be reflected. That will open down. And then we'll go ahead and we'll pick a +2 like we did last time. The only number we can't pick for the a is 0. Okay. Notice if we pick a equal to 0, it's just going to make everything 0, and then we wouldn't have a quadratic at all. So you can use any other value except for 0. So this one we're going to get f of x equal to 2 times x plus 5 times x. So this one's going to be a little bit skinnier than the other two. It's going to be vertically stretched. Still passes through the same intercepts. Okay, and there you have it. Those are the 3 members. Okay, I'm going to have to make a little bit of space here. So I'm just going to go ahead and compress this. And I'm going to compress this one as well too. Okay, let's try to squeeze in part C over here. So -3 and 3. There's my x-axis, my y-axis, my two roots or x-intercepts, -3 and 3. Okay, my general equation for the family is going to be f of x equal to a times. So for this x-intercept of -3, I should have a factor of x plus 3. Okay, as you can see in the pattern, it's always just going to be the opposite sign. Okay? That way, when you plug this in for x, you end up getting 0. And the next one here, +3, well, then we're going to want x minus 3. Okay, that way we plug 3 in. This all goes to 0 as well. So this is our family equation. So all the members pass through those intercepts. And just like we did before, we'll let a equal 1. So we're going to get x plus 3, x minus 3. And then we'll let a equal -1. So we'll get minus x plus 3 times x minus 3. And lastly, we'll let a equal 2. 2 times x plus 3, x minus 3. Okay, our first function will just kind of go through like this. And the red one will be reflected. It'll pass through like that. And the green one is stretched, so that'll run through like that. Nice thing about this graph is that because the intercepts are like symmetrical to each other, -3 and 3, that means the vertex should always fall along the y-axis. Okay, if you sketched it nicely, your vertexes should always be along the y-axis. Okay, let's go ahead and do this last one. So this last one will be a little bit interesting. 6 is the only x-intercept. So if 6 is the only x-intercept, then what happens is we have a graph that looks like this. Okay. Well, our members will look something like that. What's going to be unique about it is the vertex will always be on the x-axis. So let's write out a general family equation first. So we can say f of x equals a. Now, I could put x minus 6 to represent the intercept here, right? That way when we plug 6 in for x, we get 0. So, but notice this doesn't look like a quadratic, okay? If you remember this scenario, when the vertex is on the x-axis, it's a repeated root. So there's actually 2 of these x minus 6's. So it's the same x-intercept, it's repeated twice. So instead of writing it like this again, okay, we're going to just write it in that vertex form, and we're going to put it as squared. Okay, that's why this is called a repeated root at 6. So there's 2 of them, they're both 6, and on the graph it shows up just as one x-intercept. All right, so I just drew a blue graph. Let's make that one, we'll let a equal 1. Okay, that would be our first example. So we'd have f of x equal to x minus 6 squared. Okay. And then I'm just going to do one more. I'm going to cut this a little bit short so we can get on with the next example. We'll say a equals -2. So my equation would be -2 x minus 6 squared. And that one will just be stretched a bit more. Still has the vertex at 6, and it opens down. Okay, so there are still many members that will have that same x-intercept. Okay, that is it for the first example, showing us how we can determine a family of quadratic functions. Okay, that was the family for the one in question B. And once we have the family defined, it's then very easy to come up with additional members. Okay, all we have to do is play around with that number for A in front. Okay, I'll see you in the next video.